this train hasn't been validated yet, so we don't throw that in the motion model. It requires 2 more rules in order to validate it. One is that it has to have 2 users on it, which means that they would have to be traveling at the same time, they would have to have all similar data, and that pretty much ensures that if you are trying to spoof the system, you would either have to have a friend with you or another phone. And that's possible, but they don't know that that's the requirement until now. The second one is that it has to have a direction associated with it. That's determined by the pool of users, and there's a simple algorithm there that just determines the direction. And until these rules are met, the train isn't validated, and you don't see it on the website. I'm going to throw it over to Abin to talk about the website now.
Thanks, Moses. So our website is T-Nav.info, so anyone who has access to internet now to check it out. So our website is developed using the following technologies: HTML, JavaScript, JSP, Java, Eclipse, Google Maps API, and Adobe Photoshop and Premiere. So this is a screenshot of our homepage, and the website has 2 main features. So first, the user could log on to the website and check when's the next train arriving at any of these B-line stations. So for example, if I want to check when the next train is arriving at Chestnut Hill, I would just click on Chestnut Hill and the following window appears with the time distance for both inbound and outbound. And this would be refreshing every 5 seconds. Now the second feature is the community could make use of a website to plan the trip that would involve the B-line. So if you type in the addresses, so if I want to go from 175 Freeman Street in Brooklyn to 52 Buswell Street, I would put in the address over here and click on T-Nav. And the result is as follows. So it's going to show the walking directions from the start address to the nearest station of the B-line. So in this case it's St. Paul Station. And you get off in BU Central. And then it's going to show the walking directions to the destination address. Moreover, it's going to show the time at which the next train is going to arrive at St. Paul Street. And so those are the 2 main features of our website. So the budget for our project is, so we have to pay for the T-Nav domaining, the data plan, activation fee for Musleh and Ajayakumar, which totals to around $400.
So now we're gonna show you a live test. We have 2 people actually on the trains right now, and we're gonna try to see. We have another feature on the website, which is a live map, where we'll show you exactly where the train is. So we're gonna try to go to our live map. So if you zoom to user, this should show us the users that are on the train. So right now we have a user at Harvard Ave.
Nice.
So this is one of the users. And it shows that's the user number, user ID number.
The other user seems to have a problem with the cell phones. We're using the Motorola Abin phones, which instead of having an assisted GPS system where it uses triangulation from cell phone towers, it has actually a specific GPS chip like you have in your car GPS. And it takes a long time for the cell phone to acquire the data. And once you're moving with that cell phone, it makes it especially hard. So sometimes it might take up to 5 to 10 minutes to get a good GPS coordinate. Yeah, we'll probably show you what the estimates are for that one user in Harvard Ave, hopefully.
So he's going inbound, which is right because he left from BC, and it's going to take him about 3 minutes, plus or minus 1 minute to get to St. Paul Street. We can check BU East or BU Central. It's going to take them about 5 minutes, plus or minus 2 minutes to get here, to get to BU Central. The other features we have, so for the users who would like to be part of this community and actually when they ride the train and they want to turn on the application so they can help us estimate when the train will be arriving to certain stations, they can go to the download over here and they can download the JET and jar files for the Nokia S60 and also for the Motorola i425. So we'd like to thank Professor Babakia, Professor Wayne, and Professor Pisano. We'd like to thank Professor Starobinsky, and we'd like to thank Dr. Tao Wu from Nokia Phone Research Facility, that's in Kendall Square, and we'd like to thank our GTS too.
Anyone who wants to join this.
Volunteers for taking the right.
Any questions? Multitude of questions. Let's start from the left there.
Okay, so the first question is, why do you use cell phone to cell phone, or why don't you use the positioning from the train to your cell phone?
Can you explain
Alright,
further?
so for instance, it requires somebody on the train to have the same program, and
Right.
in order for it to work. So what if like there's nobody on the train that has the software? Why don't you just use the position from the train that's known and more accurate? Because they have to track that train more than
Correct.
right?
So you're saying something in sort of putting the GPS or some kind of signal beacon on the train itself.
Yeah, well it's already there.
Right. The idea of this, I don't know if the Beeline actually has any.
You don't.
They don't have
Right. They don't have any system that will allow them to know when the train is above ground. I don't know about underground. It's a whole different story with the system. But yeah, the whole idea was to go around the MBTA to do this as a community of users because there's no involvement of MBTA in this project, and it's really hard for them to come in or us to bring them this idea, and they really don't like people from outside interfering and doing technology, changes the MBTA, and they're really happy about it. So we decided to do this. I mean, this was Professor Starobinsky's idea, and the idea behind this was once you have enough users with these cell phones, which are out there, why spend money for hardware that you can mount on the T's to send GPS coordinates, like let's say NextBus does for bus prediction. There's a company like that. The idea would be here to use the user's cell phone, which is already on the T, to provide that data. It's just the willingness of the user.
One more question. So, based on the model, how accurate are your predictions on their arrival time?
Our requirements in the design stage requested that we would put, as you saw, the actual minutes plus minus deviation, and the deviation will change based on the prediction table data. So if we have enough data in the system, it becomes more accurate. But right now, it's after testing, it's about what, 10 to 20% error on the T during the daytime schedule and rush hours. We haven't really run tests for night time schedule.
Definitely cool stuff. I was wondering about the packs you said. They're all on UDP, and you have the train creation rules, correct? And that'll prevent someone from spoofing it. So in the packets, you don't actually take any information from the user phone. They're just raw data with timestamps and geolocation. But it doesn't seem like you have any incentive to keep usernames or passwords private at all either. So what's from stopping you from getting a million username credentials, sending out a bunch of...
The username, we didn't go into much detail. It's a design issue. It's a randomly generated number by the cell phone application so that the program on the server knows which GPS points to refer to that user. So we know, okay, this is this guy going from Harvard Avenue down to Blandford and not mixing up other cell phones. So it's nothing that's private to the user. The password is used to protect the system from someone who would like to spoof the system with their own cell phone application, because they're really easy to make if people have, if you have some idea of Java development, you can create a program like this. And if you don't know how the password is created, the encryption and decryption algorithm on the server side, people can just flood the system with stupid data and make the system useless. The only prone thing to say, the other thing about that is that we haven't protected this from a denial of service attack. So if you know the port number on the socket that the server is running, which I won't say, you can just flood the system with UDP packets, and it will deny any data coming in from the cell